your screen. Welcome back. We're going to get started on the do now. Hello, Anam. Hi, Karabo. Hi, David. We can get started on the do now. It was what we sort of ended off last time doing, where we were writing ratios. So you can either write it in terms of small letters or big letters. It really doesn't matter. I'm well, thank you, David. How are you? Good evening, Sihle. How are you? Hi, Zayan. Welcome back. So nice to see all of you here. Who have I not said hello to yet? Karaba, I've greeted. So Sihle, Jared, Akila, Sinehlanhla, welcome back. So nice to have everybody here with us again this evening. Nolwazi, welcome. Okay, so I hope you guys have got your calculators because you're going to need them for this lesson. And then, of course, your book and your pens and pencils for writing. Okay. Oh, wow, Tatuka, you're on the road, but you're joining. Awesome. Okay, so you're just going to have to listen to Tatuka. I don't know if you're going to be able to write much, but never mind. It's nice to have you with us. Okay, so Tisetso, welcome. Naileti. I hope I've said hello to everybody. Tatuka, have you got your hand up? Or is that... Hey, Katlejo, welcome back. And Harrison too. Welcome back, Harrison. Yes, it's lovely to see you too, Katlejo. Welcome back. Yes, yeah, hi from Akila, thank you. No, I can't see you. That's okay, Katlejo. At least we can talk to one another over the chat, so... Hi, Naileti. Thanks for your message. Oh, and a message from Harrison too, saying hi, everybody. That's cool. I am in Tabasing. I am doing good. How are you doing? Welcome back. So glad you're with us. Okay, so some of you may not have finished, and if you haven't, it's really not the end of the world. I want to get started on this because there's quite a lot for us to get through in this lesson. And I really do want us to get stuck in. So what I'm going to do, just to save a little bit of time, is I'm going to write down the answers over here instead of asking you. I mean, we will have more of a discussion down here. But anyway, if I do anything wrong, then please let me know. Okay, so hopefully for sine theta, I'm using little letters. So I'm writing m over n. For tan theta, I'm writing m over o. For cos theta, I'm writing o over n. Do you agree with me with the little letters? Have I made any mistakes? Hope not. Okay, so when it comes to sine alpha, I would have said O over N. When it comes to tan alpha, I would have said O over M. And when it comes to cos alpha, I would have said M over N. Okay. I just want to point something out to you, and this really is only going to become more important to you next year in grade 11, but I'm just showing you this now. If you have a look at what sine theta equals, do you see that it's the same as cos alpha? Did anybody else notice that? And similarly, the cos of theta is equal to the sine of alpha. Don't know if anybody noticed that, but that will become important to you next year. Okay, so now there are a couple of more difficult questions. All right, so now I'm going to go over to you guys. So who would like to do cosec theta for us? Go for it. What do you think it should be? What should cosec theta be? Naileti, do you know? Want to try and answer? Okay, well, I mean, part of our lesson today, okay, all right, that's fine. I just thought maybe if there were people that understood this from the last time, but it's no problem if you don't. Okay, we're going to talk about that. We're going to talk about the reciprocal ratios. Okay, so do you realize that all of these over here are, we chatted about them a little bit at the end of the last lesson, and we've referred to these as our reciprocal ratios. Okay. Do you understand what we mean by the word reciprocal, though? Is that a word that we understand? Do we know what the word reciprocal means? Indeed. Indeed. So Tutuka's put a good thing into the chat. He said swap over, opposite. Yes, I guess Katlejo it could be. What they're talking about specifically with the reciprocal, and I'm just going to move the board over and then we can come back to what we were talking about, is I'm going to give you an example, okay? So look at this, okay? The reciprocal of 2 over 3 is 3 over 2. So what have I done? So when I've worked with a reciprocal, what have I actually done?
You swap the positions.
Absolutely. I see here you've come with one of your lovely explanations again. Absolutely. I've swapped the positions of the numerator and the denominator. What does Celia says? An expression of functions is indeed. Okay, so in other words, if I multiply these two together, I would always end up with 1. Okay, quite right. So a reciprocal Simply put for us, okay, so if I say we have the number 3, right, the reciprocal of 3 is 1/3. I hope everybody was thinking that as well. Remember, underneath every single integer is always, can always be written over 1. Okay, so a reciprocal happens when we swap the position of the numerator and the denominator. What was in the numerator is now in the denominator, and what was in the denominator is now in the numerator. And we can do the same with our trig ratios because they are fractions. So we can move what was at the bottom to the top and what was at the top to the bottom. Okay, so each of the 3 trig ratios has a reciprocal, right? So these reciprocals are called cosec for short, sec, and cotangent, or cot for short. Okay, so we just know it as cosec, sec, and cot, right? So cosec is the reciprocal of sine. So instead of it being sine theta, cosec is 1/sine theta. All right, so it's the reciprocal. Sec theta is the reciprocal of cos theta. And the last one, cot, is the reciprocal of tan theta. So this is important for you in grade 10. The good news is we don't work with cosec, sec, and cot in grade 11 and grade 12. But in grade 10, they will expect you to be able to calculate the values of cosec 39 degrees or something like that. And I'll show you now with some examples what we would need to be able to do. Okay, so make sure that you've got that written down so that you know that cosec is the reciprocal of sine theta, that sec theta is the reciprocal of cos theta, and that cot theta is the reciprocal of tan theta. Okay, so if sine theta, let's just pop this on the side over here. Remember, sine theta is opposite over hypotenuse. So that means if we do the reciprocal, it means that cosec theta is hypotenuse over opposite. Can you see how the positions of the numerator and denominator have swapped? Similarly, sec theta, let's just write in what cos was first. You'll all recall cos theta is what, Cece? What's cos theta? Adjacent over hypotenuse. Okay, and then tan theta very quickly is opposite over adjacent. So we all know that. Okay, so with sec theta, we are swapping hypotenuse and adjacent. Cool. And then sec theta is adjacent over opposite. All right, everybody happy with that? And that's also important. Okay, so what you can do if you want to is you can just use H, O, and A. You don't have to write, oh, you're having trouble with your keyboard. Okay, Celia. Oh, well, I hope your trouble improves, but I'll bear that in mind as our lesson moves on. Okay. Now, I'm going to show you where we would use this in terms of some calculator skills. So this is also something that's going to be important for you, right? We want to try and use our calculators. I hope you've all got your calculators with you. Oh, hang on a second. Before we do that. Okay. Do you want to practice this? Before we move on to calculator skills, I'm just mindful of the time. So if we have a look at this diagram, okay, let's just quickly do this first. If I want to write sine theta, okay, so fill out the first one, all right, in terms of little a, the little b, the little c. Let's see who we can ask. I know Celia said she was having problems. Katlejo, can I ask you? If I want to write sine theta in terms of A or B or C, what would I write? What would sine theta be in this triangle? Do you know, Katlejo? C over B. Okay, so Tutuka's put the right answer in here. So Katlego, A is the side adjacent to theta. Remember, sine theta is opposite over adjacent, just like Tutuka put in our chat. So C over B. So what then is cosec theta? You can try this one too, Katlego. Cosec theta would be, in terms of B and C, it would be? Can anybody help, Katlego? What would cosec theta be?
B over A.
Indeed. Not B over A or B over C?
C.
B over C. Good. Good. Perfect. So cosec theta would be B over C. Do you see how this works, grade 10s? So cosec theta in this case is going to be, who else can we call on here? Naleti. Do you know what cosec theta would be in terms of this triangle? Sorry, cos theta, what it would be in terms of this triangle?
Miss, I think it's A over C.
A over C for cos theta. Okay, I agree with you that A goes at the top, but I don't agree with you that C should be at the bottom. Remember, cos theta is adjacent over hypotenuse. What letter is representing the hypotenuse in this case? Okay, there we go. All right, so Nizala, that's right. A over B. Palisa, well done. A over B. Good. Okay, never mind. It doesn't matter if we get stuff wrong. We can always fix it. Okay, so Palisa, what should sec theta be? What should sec theta be? If cos theta is A over B, then sec theta must be B over A. Good, well done. That's great. Perfect. Right, and then the last one, tan theta. Tan theta is supposed to be? What do you think, grade 10s? What should I write? Well done, Harrison. C over A. Beautiful. Okay, so Harrison, that means that cot theta is going to be? Cot theta is?
A over C.
Beautiful. Okay, so your teachers may give you something like that in a test. Something like this would be considered sort of quite easy, and that it would be something that everybody would be able to do. And then the questions would become a little bit more difficult, and that sort of leads into the calculator work that we're looking at now, where we've got to use our calculator to work out the values of things. Okay, so are there any questions, or can we move on? I'm going to move down here. If there are any questions, then please do call on me. Okay, so now I hope all of you have got your calculators here, okay? Katlek, this is very hard for you. It's okay, Katlek, that's fine. It will become easier with time. These things are difficult in the beginning, always when we learn something new. All right, it doesn't matter. You're trying, and that's all that counts. Okay, so just be patient with yourself. Okay, no stress. All right, who knows how to work out cos 48 on their calculator? Do you know what to do? Do you know what to press on the calculator? So if your calculator switched on, okay, you're going to press the cos button. You should find it in that row of buttons, or in all those buttons towards the top of your calculator. You'll see sine and cos and tan. So you press cos, 0.66, Sihle says. And as well as you said 0.68. What did I get? I got 0.67. Okay. All right. Let's just be very careful. The one thing I should have said to you that I didn't tell you in the beginning, make sure that when you're working with trig, that your calculator is set on degrees, on D. Okay, so if it's not, if you've got a Casio, then you'd press Shift 9, 3 equals AC, and that would reset it. But it must be, your calculator must have a D. If it's got an R or a G up at the top along the face where you read the numbers, then you'll be in trouble. Okay, but yeah, 0.67, I quite agree. All right, who knows how to work out 2 times the sine of 35? What would we do now? Anyone know what to press on the calculator? One comma 1.5. I got the same answer. All right. 1.45, Sihle. I don't know why you're getting 1.45. Did you press 2? Yes, Naileti. So that's 2 times sine 35, close brackets, press equals. Okay, so you said 1.15. Okay, there we go. Maybe it was just a little typo. Okay, perfect. Now what do we do? How do we get tan squared 81? Does anybody know what to do there? Right. Do we know what this means? So when we see something with a square in it, this is actually what we are doing. We are taking the tan of 81 degrees and we are squaring it. That's what it means. Okay, so tan squared 81 is the tan of 81 squared. Do you know how to enter that on your calculator? You first have to open a bracket. No. So what you're going to do is this Nizzle. You're going to press brackets. Then you're going to press tan. Then the calculator will automatically bring up a bracket for you. Okay. So put in 81. Then remember to close the bracket around the 81. And then you must close the big bracket as well. Okay. So it's very important. If you've opened 2 brackets, you must close 2 brackets. Otherwise, your calculator will give you an error. Okay, so it's bracket tan. Automatically, the bracket comes up. You pop in the 81, close bracket again, and then square your answer. Okay, so Naileti says 39.9. Okay, so you rounded to 1 decimal place. That's fine. That's perfect. Well done, Naileti. Rabin, you're getting 0.66. Sihle, 40. Okay, no, we're rounding to 2 decimal places. So yes, Sihle, you're very close. Akila 39.9, yes. Okay, but now, Rabin, did you do exactly what I said here, where you pressed bracket, tan, 81, close bracket again? Yes, there we go. And then press your square button. Okay, good job. Well done, Palesa. Well done, Nizol. You guys got that right too. And Akila, good. Rabin, is that making more sense now? Okay, so let's see what you guys get. Think so. Okay, well, tell you what. Just try it one more time and see that you get the same answer. Should I let you guys try number 4 and number 5 on your own? You could even try up to number 6 on your own. All right, and then we'll talk about what you would need to do with number 7 and number 8. So I don't know if you realize there, but there are some reciprocal ratios. So I'm going to have to explain those to you. Okay, so you try 4, 5, and 6, and let's see how that goes. All right, and then we're going to mark it right now. If you've got any questions or you're stuck on anything, then please speak to me. Okay. How's everybody doing? Are you managing? Any questions? Okay, so Akila, you said for number 4, you got 2.71. I'm also going to take a quick sneak peek at my answer. There we go. I got the same answer as you. Well done, Akila. We agree on that. Okay, cool. All right. Palesa, oh, good. You tried number 5. What did you get? 0.44. Okay, I got 0.22. Yeah, see, that's what I got as well. Palesa, I wonder what went wrong there with 0.4, because that's exactly double. Akila says 0.56 for the next one. There we go. Good job. Well done, Akila. Any idea what you might have done wrong, Palesa? Okay, so is everybody okay with that? Did you get the same answers as Sihle and Akila and Palesa? Not Palesa, sorry, and Akila the first time. Is that all okay? Thumbs ups or thumbs downs? Yeah, sometimes, Palesa, we just press the wrong thing on the calculator. We don't even realize it. Okay, all right. Thanks, Nizol. Thanks, Naleti. Yes, well, Sihle, what you're supposed to do when you round into 2 decimal places is you actually need to look at the third place, all right? And if the number sitting in the third place is 5 and above, it pushes the number in the second place up by 1. If the number sitting in the third place is 4 and below, then that second number stays the same. Okay, that's how you would round correctly to what's wrong with me? To 2 decimal places. Okay, I hope that makes sense. All right, so I'm assuming then that you guys are okay. Please stop me if you've got any questions. I don't want to just move on and then you feel cool and then you feel left behind or like you're uncertain or something. Now, did you notice on your calculator, grade 10s, there's no sec button? Did you see that? There's no sec button. There's only sine and cos and tan. All right. There's also no cot button either. So now we have to have a special way of being able to work out what the sec of 34 is, because we can't work out the sec of 34 in the same way that we work out the cos of 34, for example. Okay, shift. Unfortunately not, Jared. Do you know what the shift button does? The shift button tells your calculator that it's working out an angle. So in this case, it's not the shift button. So what you want to do, okay, first of all, let's just think about what sec 34 is equal to. So sec 34, the sec function, there we go. Okay, so Harrison told us. Well done, Harrison. It's 1 over the cos of 34. What does the HYP button do? Hang on, I'm just going to have a look at my calculator. I don't have my calculator here. I don't think you need to worry about a button that says HYP. I can't think off the top of my head. But there are a lot of other functions that these calculators can work with that we don't need to worry about. Okay, but HYP doesn't have anything to do with what we're doing in trig. Okay, all right. Okay, so now do the rest of you understand what Harrison did here, where he wrote the sec of 34 as 1 over the cos of 34?
No,
Does that
Miss, I
make
don't
sense?
understand.
You don't understand? Okay, and then Sihle says the answer is 1,2. I got 1,21, yes. Okay, so just careful about rounding to that second place. Okay, if the number sitting in the third column is 5 and above, then it's got to push the number in the second column up by 1. That's okay. Yes, you use the reciprocal ratio, Carol. That's right. It's okay. Have you forgotten rounding off? Okay. I actually need to try and figure out a way how I can get a calculator on the screen, and then we can talk about it, but I don't actually know how to do that as yet. Okay, so the cot of 49. So if we recall, cot is the reciprocal ratio of tan. Okay, so what we would do here is we would write that's it, Harrison. Well done, you've got it. Okay, so cot 49 is the same as 1 over the tan of 49. Okay, and what did we get in this instance? Did you get 0.87? Am I right? Okay, so Sihle also got 0. Gives me a math error. Do you know why, Naileti? Okay, when you are putting this into your calculator, right? Some calculators are very fussy. You've got to close the bracket. If you use the fraction button and it opened a bracket here and you don't close it, it goes, there we go, Sihle, it goes math error. Okay, so you've got to close the bracket. Try it again and see what happens. Did it work correctly now, Naileti? Cool, no problem. Okay, so you guys are really good at this. It's amazing. Well done. Okay, good job. Now, let's have a look at these difficult ones. All right, so I said number 9 and number 10 are difficult. All right, so I'd like you to try these as well. Remember, if you use the fraction button, you have to close the bracket afterwards, okay? Otherwise, it's going to happen what happened to you now later, where it's going to give you a maths error. So try number 9 and number 10, grade 10s, and let's see if you get the same answers that I got. Hopefully, I didn't make any mistakes. And then you can share your answers with each other and with me on the chat. Okay, cool, Nolwazi. All right, Sihle, you got the same answer as Nolwazi. All right, so that's looking good. Anybody get a different answer for number 9? Anyone get something different from 2.76? You also got that, Katlecho. Good, well done. You see, you said in the beginning that this was hard for you, and look, now you're doing the difficult questions. That's great. Good going, well done. So yeah, let's take a sneak peek at what my answer was. Oh, there we go. I got the same as you. Okay, so 2.76, good. Okay, and then Sihle says for the second one, it's 2.08. All right, anybody get the same answer as Sihle? Anybody get a different answer to Sihle?
Ma'am, are we rounding off to 2 decimal places?
Yes, Tutuka, you are supposed to normally always round off to 2 decimal places. That's the usual. Okay, so yeah, when I'm teaching in the classroom, I always try and make my children round off to 2 decimal places because that's generally what you would do in all tests and exams. Okay. Okay, so Akila and Nazol and Karabo and Inam. Okay, you all got the same answer. Okay, let's see what I got. Ha, okay, well done, brilliant. Good stuff. Well done, grade 10s. Very nicely done. Okay, any questions on that? If not, then we can move on to the next thing. Oh, good, Sihle, well done. All right, so I hope everybody else feels like Sihle did. Those lovely thumbs ups. Perfect, perfect, perfect. Okay, so now the next thing that I wanted us to be able to talk about today were special angles, okay? And when it comes to special angles, you are unfortunately, is it getting easier for you, Nilete? That's fine. Inam, do we have to show our working out when we do sums like this? Inam, for something as simple as 2 sine 35, no, you don't. The only ones here where you would actually have to show some kind of working out would be for number 7 and number 8, where you would show sec 34 is written as 1 over cos 34 and then write down the answer, and that would be it. Okay, there wouldn't be anything further than that. All right. Okay, so let's get back into special angles. Have you done special angles in class? If you have, then just give me a thumbs up if you've done special angles. So Sihle says no, that's fine. Anybody else done special angles at school already? Okay. Okay. Sinahlanhla says no. Okay, that's fine. It doesn't matter. Inam says no. All right. Adewale, you're right. Yes, 60, 45, 90, 0, and 30. These are all our special angles. Quite right. Okay, so grade 10s, what we mean when we talk about some trig ratios that are special angles. Have you noticed, as is the case with all of these numbers that we were working with up here, all of them had lots of decimal places and we needed to round off, didn't we? Okay. But there are some angles that when we calculate them, we don't end up having to round off, right? Or we end up, well, I suppose we could round off if we wanted to. But what we do is we end up with values that can always be written in the form of a common fraction. All right, so as something over something else, right? In the case of special angles, what I would like you to take down, because that's sort of like an easier one. This is really a little bit more comprehensive, right? Our special angles are something that we have to learn, okay? And the special angles in trig are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. There are lots of different ways in which people remember special angles. There are a lot of different methods. But I've always found that learning it, like this table over here that I'm just drawing a blue block around, is the easiest way, okay? What we do is we start with y first, and then we start at 0, and we write 0, 1, 2, 3, and 4. I'm going to explain to you now where this comes from. And then we start at x, and we write 4, 3, 2, 1, 0. When it comes to special angles, the value of r is always 2, but that's only for special angles, okay? That doesn't mean that r is 2 in other cases. It's just in this case. And then what we would have done here is we would have square rooted each of these. So that's why I've got 2 here, because 2 is the square root of 4. And again here, 2 is the square root of 4. Now, if you were wondering how this works, okay, in order to work out what a special angle is, this is the part that becomes a little bit difficult. Instead of writing y, all right, y is there to represent opposite, and x represents adjacent, and r represents the hypotenuse. So we need to become comfortable with the idea that if we talk about the sine of a particular angle, let's say sine theta, traditionally, up till now, we've always written it as opposite over hypotenuse. But if we're using x and y's and r's, then we can write sine theta, any angle, and instead of the O, we would write y, and instead of the hypotenuse, we would write r. Okay, so bearing that in mind, if I now wanted to write down what the sine of theta, sorry, the sine of 30 degrees is, remember the sine of 30 degrees is opposite or y over hypotenuse or r. So now what I'd do is I'd go to this column over here and I want to look for opposite and put that in the numerator. And I want to look for hypotenuse or r and put that in the denominator. Is there anybody who knows what I should write here? So the sine of 30 is equal to? There you go, Sihle, well done. It's equal to 1 over 2. Good stuff. Does everybody know what? Yes, Palesa, quite right. 100%. 100%. Okay, so now let's try another one, okay? What if I wanted to write the cos of 30? Okay, remember cos is adjacent over hypotenuse. So again, look in the 30 column. How would I write adjacent over hypotenuse in this case?
Square root of 3 over 2.
Indeed, David. Well done. Square root of 3 over 2. Well done, Sihle. Okay, you guys are catching on to this so nicely. That's excellent. Well done. All right, here's a slightly more difficult one. How would I write, let's just create a little bit more space here. Oh, come bored. Okay, how would I write the tan of 60 degrees? How would I write the tan of 60? Unfortunately not, Sihle. The cos of 30 is not 1 over 2. So remember, cos is adjacent over hypotenuse. Adjacent over hypotenuse. Okay, so square root of 3 over 2. Yes, that's it. Okay, so square root of 1, ma'am. Okay, so are you talking about tan? So it's opposite over adjacent. Quite right. That's it. Perfect. So we could write that as root 3 over 1 or just as root 3. Good job. Well done. Okay, how would I write the sine of 45 degrees? How would I write the sine of 45?
Square root of 2 over 2.
ma'am.
Well done. Okay, excellent. Okay, great work. Well done, grade 10s. I'm really, really pleased. So now what I wanted you to do is I wanted you to have an opportunity to practice working with some questions where we are using special angles. So these you have to learn, okay? You have to learn them. Unfortunately, triggers that section in maths where you have to study. It's like history or geography. You have to learn these things off by heart. And if you learn them now in grade 10, it's just going to be so much easier for you in grade 10 and 11, okay? Because these are important for grade, maybe not so much for grade 11. We do work with them a little bit, but grade 12 special angles are really, really important. Okay, so let's go and have a look down here at some of the sorts of questions that come up, okay? Our time always goes by so quickly. So what I did is I found this little table over here, all right? And I thought that that would make your lives a little bit easier to work from this instead of having to go back to the big table and work out what's over what. Okay, so I've left out 0 and 90, and I've just got 30 degrees, 45 and 60, and I've got the cos, the sine, and the tan for each of these. Okay, so now you have an opportunity to work with special angles, but you are not allowed to use a calculator. How crazy is that? Okay, so we've got to put our calculators on the side, and we've got to work without our calculators. So now I hear you saying, well, how on earth are we going to do these without our calculators? We're going to do it just like this. Okay, so in the case of the first one, number 1, let me show you what you would do. Okay, so we want, so 1.1, so we want the cos of 45 degrees, and then the dot. Does anybody remember what the dot means?
Multiply.
Multiplication.
Indeed, Sihle, indeed, David, it means multiplication. So it's the cos of 45 times the sine of 45. Okay, so now if you've learned these off by heart, it's so easy, but if you don't know, then you're just going to come over to the table over here. See, there's cos, there's 45. Okay, so the cos of 45 is 1 over root 2, or root 2 over 2 if you put it onto your calculator. So we're going to write that as 1 over root 2. What's the sine of 45 equal to? Same thing. Can you see that? It's also equal to 1 over root 2. Okay, so now whoever would have thought that in order to be able to be good at trig, you've got to be good at fractions. Does anybody know how we multiply fractions? Can anybody remember? All right, so our rules for multiplying fractions are so important here. When we multiply fractions, grade 10s, highest common factor in them, that's when we add and subtract. No, Katlehu, we don't have to make the basis the same because we are multiplying fractions. Okay, when we multiply numerator with numerator and denominator with denominator. Okay, so to answer this, it's simply 1 times 1, which is 1, so that goes in the numerator, and root 2 times root 2, indeed, Sihle, the answer will be 2. Root 2 times root 2 is root 2 squared, and root 2 squared, it's opposite operations, so it's just 1 over 2. Perfect. All right, so are there any questions? Okay, good stuff. I tell you, no, actually it's fine. All right, you guys try. We've only got like just over 10 minutes left. Okay, so let's see how many you can try in the next sort of 7 minutes, and then we'll see where we go. If you are stuck or confused, please ask me, but you will be able to refer to this table on the side, and then you can write your fractions in. Okay. All right, off you go. So you're going to write down the question, substitute, and then the answer. Okay, so you saying that for number 1.2, you got 2 over 3. Okay, Sihle, good. Let me take a sneak peek at my answer and I'll see if 1.3, you got 3 over 4. Okay. All right, I got the same answer as you. All right, for 1.2. Okay, and then for this one, I got 3 over 2. I could be wrong. How's everybody else doing? Thanks for your answers, Sihle. That's great. How's everybody else doing? How? Oh, sorry, Katlejo. That's fine. Which one are you struggling with? Sorry, Katlejo. I'll help you. Just tell me which one you want help with. For 1.1, you got 1. Okay. Let me do number 1.1 again with you, okay, Katlejo? Don't worry, okay? Everything can be fixed, okay? It's not the end of the world, I promise, okay? You've still got plenty of time to be able to fix your issues, okay? Don't be sad. Oh, 1.2, okay. So you got 1 for 2.2. Okay, let's go through it together, right? This is what I would have done. Okay, so so Nizol, for adding fractions, then you've got to have a lowest common denominator. So you've got to make the denominators the same. Okay. We can, are you talking about 1.3? We can have a look at that now. Oh, now time's running out. It always does, doesn't it? I wish we could sit here all night doing maths together. Okay, so the tan of 30 divided by the cos of 30. Okay, so Katlejo, now you're going to substitute, right? What is the tan of 30? It's 1 over root 3. Then this line over here that I'm just making darker, that means divide, doesn't it? So I'm writing the divide sign, right? And then the cos of 30. So if I go and have a look at my table, the cos of 30 is going to be root 3 over 2. Okay, so now we've got to remember our rules for dividing fractions. Okay, so our rules for dividing fractions say that we keep the first fraction as it is. We change the divide into a times. Fine is all. I'm going to do 1.3 right after this, no problem. And then we put what was at the bottom at the top and what was at the top at the bottom. Okay, and now we multiply fractions as normals. Top times top, numerator times numerator, 1 times 2 is 2. And at the bottom, root 3 times root 3 is 3. Does that make a little bit more sense? Okay, so Nizol, you were struggling with 1.3. That's fine. Let's do that now. You got it. Well done, Sihle. Excellent. Good job. Okay, so let's do 1.3 over here, Nizol. All right, we have got the cos of 60. And to that, we are adding the tan of 45. Okay, so again, we have to substitute. The cos of 60 is 1 over 2. The tan of 45 is equal to root 2 over 2. What does it say in our table here? 45 is 1. Okay, sorry, long day. Of course, the tan of 45 is 1. I can't believe I'm being so silly. Okay, so there we go, 1. All right, so now all we have to do is add 1 to a half. So if you want to, right, you can write your answer as 1 1/2. Or if you want to make the denominators the same, that's over 1. So you've got to times that by 2 and that by 2. And then you would end up with 3 over 2 is your answer. Okay, Nicole, it's not so bad, hey? It's a pleasure, Katlego. Inam, you got confused in number 1.4. That's fine. Let's have a look at that. Okay, let's do that one next. Okay, so now we've got 1.4. So we've got 2 times the sine of 45, all right, Inam, times the cos of 45. Okay, so that gives us 2 over 1 times the sine of 45 is 1 over root 2. The cos of 45 is the same, all right, 1 over root 2. So if we, sorry, unfortunately that table is off the page at the moment. It's over here. Let me just grab it and bring it down. Okay, are you happy with that, Nizol? Okay, that's where it comes from. Okay, so the sine of 45 is 1 over root 2 and the cos of 45 is 1 over root 2. And next year you'll understand why that's true. And now let's just finish this question off. Okay, and then how do we multiply fractions? Numerator with numerator with numerator. So 2 times 1 is 2. And at the bottom, denominator times denominator times denominator. Okay, so 1 times root 2 is root 2. And root 2 multiplied by itself is 2. Okay, and 2 divided by 2 has to give us 1 as an answer. Okay, Nazol, does that make a bit more sense? Good. Okay. All right. Well done. You guys have done such great work today. And then good, Sihle, you got them all correct so far. Good. Well done. All right. Let's see about number 1.5. I don't know if anybody else managed to do that, but in 1.5, I got 1 as an answer. Anybody else get that? Indeed. Do I need to explain number 1.5 for anybody? There, we've just got to be careful about the order of operations. We've got to make sure that we multiply before we add or subtract.
Yes, please explain.
With pleasure, Ntabiseng, no problem at all. Okay, so with this one, let's just grab our table so that it's there and you can see it. Okay, the sine of 30. Okay, so we've got the sine of 30 plus the cos of 30 times the tan of 30. Okay, so there are 2 terms in this expression. Here is the first term, and there is the second term. So we've got to follow the order of operations, got to follow BODMAS, all right? So the sine of 30, when we look at our table, we can see that it's this one over here. The sine of 30 is 1 over 2. We're substituting. The cos of 30 is root 3 over 2. The tan of 30 is 1 over root 3. Okay, so when we are working in this second term over here, we are cancelling something that is the same at the top because root 3 goes into itself once and it goes into itself once down there. So what we've got is 1 over 2 plus 1 times 1 is 1, 2 times 1 is 2. Okay, and if we add a half and a half together, that would give us 2 halves, and therefore the answer is 1. Okay, and Tabiseng, I hope that made a little bit more sense. Anyway, I'm sorry, grades. Pardon?
I understand, ma'am. Thank you.
Oh, okay. It's a pleasure, and Tubby Singh. I'm glad you understand now. Okay, I'm sorry, grade 10s, but our lesson is over. So I'm going to have to hand you back to Tula. Well done. You've done wonderful work this lesson. Thank you for all your enthusiasm and for always interacting with me. Okay, so well done. All right, let's say goodbye.
Hello, grade 10s. I'm just going to quickly rush through this slide so that I can let you guys go and enjoy the rest of your evening after working really hard on this session. So we have 4 more lessons. I'm not sure if this thing is presenting yet on your side. We have 4 more lessons to go. Is it showing, Lead? Can you see on your side properly?
Yes, I
Seems
can
like
see
it's
on my
cutting.
side.
Can you see? All right, perfect.
Yes.
So we have 4 more lessons to go, and it's just 2 weeks. They're spanning over 2 weeks because remember we have 2 lessons every week. So there isn't much much to go on here, and it's just and remember we also have more. I think we have another topic after this, after trigonometry. So it's not that when we're done with lesson 6, we're just going to be done with our live classes. So you guys watch out for that. Perhaps in the next few lessons, maybe on the 4th one, I'll also include the course schedule for the following topics, so you guys can just mentally prepare for, yourself for that. Next week, we're going to be solving sides in right-angled triangles. So make sure that if you have maybe you have some time to quickly look over that in your textbook, wherever, just do that so you come to the lesson ready, and if with any questions that you might have already. And of course, the homework for this week, remember we encourage you guys to, after this lesson, to go to your app and do some activities and lessons so you solidify your learning. Go to pick a topic on your Atobi app, click on trigonometry, as you can see here, and then do the trigonometric ratios and reciprocal trig ratios. And then make sure that you do the lessons on this and maybe even attempt the quizzes just to make sure that you understand. And just to announce once again, I think you guys would have received the message on your Atobi apps. But at the moment, we've discontinued the one-on-one tutoring because we found that a lot of students found more value in asking questions in these live classes. So you will no longer be able to ask a question one-on-one and receive a video. Rather, we prefer that you come with these questions here in these live lessons if they correspond, I guess, with the topic. If not, just try to watch the live lessons and then we'll see how we figured it out on these live lessons. So I'm sure we'll also have revision for the exams. Lead, do you know if we'll have? Yes, yes.
I don't know if there is revision. Well, I suppose there would be. There would have to be revision for grade 10s and grade 11s, but I imagine that would be sort of more towards the end of the year. But I'm sure we will do that on paper 1 and on paper 2. Yes.
Yes, where we cover sort of everything and you come with your questions. So
Indeed.
we've got you covered with, and we of course will give you more information as the time gets closer. So yeah, I think that's it on my side. I'll see you guys tomorrow. Remember, tomorrow we have the math, and I saw a lot of you guys there for the math anxiety workshop at 6 p.m.
Oh, wonderful.
with the mentors. You guys were wonderful. And tomorrow we're also inviting your parents. You can bring a parent just so they can learn a lot of things. So you learn how math anxiety may affect your performance in maths and how to overcome it. And the workshops are run by the mentors. The mentors all have backgrounds in psychology. They're all they all have degrees in psychology, and we just try to help you guys to get a grip of not just the numbers, that's Lee's job, but we try to see what other factors may affect your well-being as a student. You know, we know you're not just a academic machine, but there's more to you. And we have a lot of nice conversations there. The learners from Watobi from different grades. You get to interact with other people from different provinces who think differently. It's a really nice interactive space. So make sure you join us tomorrow at 6 p.m. And as usual, you get the link on your Watobi app on the chat. So I'll see a lot of you guys tomorrow. Hopefully all of you. And I think that's it for me. Do you have anything to add, Lee?
I don't. Well done, grade 10s. Have a wonderful weekend, and we'll see you again on Tuesday.
Bye, guys.
Bye.